Examples on extreme value. Example number 1. Find local maximum. Find local maximum and minimum and saddle point and saddle points of the function f of xy is equal to 4xy minus x raised to 4 minus y raised to 4. So the step first, we want to determine critical or stationary point. Step first, critical points. Now to find the critical points, consider f of x is equal to 0 and f of y equal to 0. Now f of x is equal to 0 implies here f of x is equal to 4y minus 4x cube. When we take a partial derivative with respect to x, means what y is constant, and when we take a partial derivative of f with respect to y, then x is constant, so 4x minus 4y cube. So f of x is equal to 0 implies 4y minus 4x cube equal to 0 and 4x minus 4y cube equal to 0. So this implies 4 is not equal to 0, implies y equal to x cube, and this implies x is equal to y cube. So if we substitute here the value of y is equal to x cube, we get x time equal to x cube raised to cube. So this implies x is equal to x raised to 9, and this implies x minus x raised to 9 equal to 0. So if we take x outside, we get 1 minus x raised to 8 equal to 0. From this we get x is equal to 0 and x raised to 8 is equal to 1, implies x is equal to 0 and x is equal to plus or minus 1. So now x is equal to 1 and x is equal to minus 1. So if x is equal to 0, then what is y here? Y is equal to x cube. Y is equal to what? X cube. Then y is also 0. Y is 0. If x is 1, y is also 1. And if x is minus 1, since y is equal to x cube, x is also minus 1. And therefore critical points are 0 0 1 1 and minus 1 minus 1. Now we want to determine nature of this critical point by using second derivative test. Step 2, second derivative test. So here f of x is equal to, now what is f of x? F of x is equal to 4y minus 4x cube. So f of x is equal to minus 12x square. What is f of y? F of y is equal to, this is f of y, so f of y is minus 12y square. And what is f of xy? The derivative of f of x with respect to y. So this is f of x, the derivative of this function with respect to y is equal to 4. Now at first critical point 0 0, first at 0 0. So f of x 0 0 is equal to 0, f of y at 0 0 is equal to 0, and f of xy 0 0 is equal to 4. So therefore d is equal to f of x f of y minus f of xy square. So this is 0 minus 4 square is equal to minus 16, which is less than 0, and therefore 0 0 is saddle point. What? Saddle point. Number 2. Now 1 1 at 1 1. Now what is f of x 1 1? It is minus 12. since f of x6 at 1 1, it is minus 12x square, so it is minus 12. F of y at 1 1, it is equal to minus 12y square, so this is equal to minus 12. And f of xy at 1 1 is equal to 4, and therefore d is equal to f of xx f of yy minus f of xy square is equal to, this is equal to 12 into 12, 144 minus 16, which is greater than 0, and a is that is f of xx is less than 0, and therefore 1 1 f of xy is local maximum at 1 1 at 1 1. Similarly, number third, at minus 1 minus 1, now f of xx minus 1 minus 1 is equal to, now minus 12x square, so again it is this minus 12. F of yy minus 1 minus 1 is equal to minus 12, and f of xy at minus 1 minus 1 is equal to 4. So d is equal to f of xx f of yy minus f of xy square is equal to 144 minus 16, which is again greater than 0, and f of xx is less than 0, therefore at minus 1 minus 1 f of xy has local maximum. Next example number 2. Find maximum and minimum value and saddle point. Same example. Find local maximum, local minimum and saddle point for the function f of xy equal to x square plus y square plus 2 divided by xy. And local maximum, local minimum and saddle point. So here f of x is equal to, step first, critical point. Now to obtain a critical point, find a partial derivative with respect to x. So it is twice x minus 2 divided by x square y. And f of y is equal to 2y minus 2 divided by xy square. Now f of x is equal to 0. F of x is equal to 0 and f of y is equal to 0 implies twice x minus 2 divided by x square y equal to 0, and twice y minus 2 divided by xy square equal to 0. So now from this we get, if we cancel 2, we get x is equal to 1 divided by x square y and y equal to 1 divided by xy square. From this we get x cube y equal to 1 and xy cube equal to 1. So if we add these two equations, we get x cube y plus or subtract these two equations, not add. If we subtract these two equations, xy cube minus xy cube is equal to 1 minus 1 is what, 0. If we take xy outside, then we get x square minus y square equal to 0, as xy is not equal to 0. If xy equal to 0, what happen here? This is what, undefined. F of xy is what, undefined. So if xy is not equal to 0, now since xy is not equal to 0 implies x square minus y square equal to 0, and this implies x square equal to y square, and this implies x is equal to y and x is equal to minus y. So we get some condition on x is equal to y and x is equal to minus y. So if first x is equal to y, then since x cube y equal to 1, x cube y equal to 1 implies x raised to 4 equal to 1. This implies x is equal to 1. Now if x is equal to 1, then y is also 1. Since x is equal to y is also 1. And if x is equal to minus y, then x cube y equal to 1 implies minus x raised to 4 equal to 1. So this implies minus x raised to, and this implies x raised to 4. This implies x raised to 4 is equal to x raised to 4 is equal to minus 1, which is not possible. Minus x raised to 4 equal to minus 1, which is not possible, and therefore there is only one critical point, 1 1, and therefore critical point is what? Critical point, this is not possible. Okay, so critical point is what? 1 1. Now apply the second derivative test. Step 2, second derivative test. So what is your f of x? F of x is equal to twice x minus 2xy square. So f of xx is equal to 2. F of xx is equal to 2 minus twice x 2, and derivative of 2x square is equal to 2 by x square is equal to minus 4 divided by x cube. So minus 4 divided by minus become plus 4 divided by x cube y. Similarly, this is f of xx, f of y is equal to 2 plus 4 divided by xy cube, and f of xy is equal to, what is f of xy? F of x, this is f of x, so f of xy is equal to, this is 0, this is minus, it is 2x square y square, 2 divided by x square y square. So now f of xx11 is equal to, at 1 is equal to 2 plus 4, so it is 6. F of yy at 1 is equal to 6, and f of xy at 1 is equal to 2. So f of xx, f of yy minus f of xy square is equal to 6 into 6 minus 4, so this is 36 minus 4, that is 32, which is greater than 0, and f of xx is greater than 0. F of xx is what? 6, which is greater than 0, and therefore at 1 f of xy is local minimum. Next example number 3. Using Lagrange's multiplier. Use method of Lagrange's multiplier to maximize Lagrange's multiplier. To maximize the function f of xy z is equal to x square plus y square plus z square subject to the constraint x plus y plus z equal to 1. So now first find the Lagrange's multiplier equation f minus lambda g equal to 0. So here f is equal to, this is g is equal to what? Here g is equal to x plus y plus z minus 1, and therefore Lagrange's multiplier equation is x square plus y square plus z square minus lambda times x plus y plus z minus 1 equal to 0. Okay, this is the Lagrange's multiplier equation. By using this equation, we are going to determine critical point. So step number 2, critical points. For that, find f of x minus lambda g of x is equal to 0, f of y minus lambda g of y equal to 0, f of z minus lambda g of z equal to 0 and g equal to 0. These are the four equations. By using these four equations, we are going to determine the critical point. So f of x is equal to implies twice x minus lambda equal to 0, twice y minus lambda equal to 0, twice z minus lambda equal to 0, and g is equal to 0. G is what? X plus y plus z equal to 1. So using this equation number 1, 2, 3 and 4, we want to determine critical point. Now from equation 1 implies twice x is equal to lambda, from 2 twice y equal to lambda, and from 3 twice z equal to lambda. Now one side is equal implies other side is also equal, so we get twice x is equal to twice y equal to twice z. So this implies x is equal to y equal to z. Now if we substitute this x is equal to y equal to z in the equation number 4, here we get equation 4 becomes thrice x is equal to 1, and this implies x is equal to 1 by 3, or this implies x is equal to 1 by 3. Now since x is equal to y equal to z implies x is equal to 1 by 3, y is equal to 1 by 3, and z is equal to 1 by 3, and therefore critical point is equal to 1 by 3, 1 by 3, 1 by 3, and f of maximum value is f of 1 by 3, 1 by 3, 1 by 3 is equal to 1 by 9 plus 1 by 9 plus 1 by 9. Since what is f of x y z is equal to x square plus y square plus z square. What is f of x y z? X square plus y square plus z square. So this is equal to 3 by 9 is equal to 1 by 3. So maximum value is 1 by 3 at point 1 by 3, 1 by 3, 1 by 3. Okay. So this is the answer. Maximum value of f is equal to 1 by 3 at 1 by 3, 1 by 3, 1 by 3. So this is the answer.